friends, welcome to Legend Lens, and today we're going to have a look at polar form of a complex number. Now we can actually represent or express a complex number in three forms. We have the vector form, the polar form, and the exponential form. The vector form, I think we've already seen that, which is in the form of a plus bi. So today we're going to have a look at the polar form, and in subsequent videos we look at the exponential form. The polar form is in the form of r cos theta plus I sine theta. Alright, so let's see how they came across this polar form. Now I'm going to use this Argand diagram to illustrate how we actually represent a complex number in the polar form. Now there's a complex number in the vector form where it's a plus bi. R here represents the length of this vector, which is AB over here. Now what we apply here is the Pythagoras Theorem. We can actually see that this is in the form of a right angle triangle, so we apply the Pythagoras Theorem to find the radius or the r. So now r square becomes a square plus b square. And the way we get is a square plus b square or square root. Alright, now r is what we call the modulus. So in some, if you see them represented by mod z. So whenever you are asked to find mod z, maybe you are given a complex number in the form of a plus bi, and you are asked find mod z, then they are actually talking about finding the r, which is the length of this complex number you see here. And so mod z becomes a squared plus b squared. It's as simple as that. Now, how do you find the angle? With the angle, we apply tangent. So now tan theta becomes b out of a. Tan, we know it to be the opposite over the adjacent. So opposite becomes b, and the adjacent a. So theta now becomes tan inverse of b out of a. So that's how we find the angle. Now let's find the sine and cos of the angle and see what happens. So sine of theta, sine, we know it to be the opposite over the hypotenuse. So in this case, our opposite is the b and our hypotenuse r. So making b the subject, we get r sine theta. Let's call this equation 1. Then our cos adjacent over the hypotenuse. Our adjacent here is a, our hypotenuse is r, so we get a being equal to r cos theta. Let's call this the equation 2. Now our initial vector, which is AB, being equal to a plus bi. In place of a and b, we put equation 1 and 2 over there. So what do you get? You get r cos theta plus r sine theta. Now there's a common factor here, so we factorize it out and we get r cos theta plus I sine theta. So this is what we call the polar form of a complex number, where R is the modulus, which is mostly represented by mod z, or simply R is the square root of a squared plus b squared. Then our theta, which we call the argument, or simply the angle, is tan inverse of b over a. Alright, so let's look at an example and see what happens. So an example here, we have z to be equal to 4 plus j3. Well, let me be consistent here, I 3. So our duty in this into polar form, and we know our polar form should be in the r cos theta I theta. It's a matter of finding our r theta from this. So r now becomes, in this case, our a 4 and b becomes 3. So we get 4 squared plus 3 squared. Then r becomes 25, r becomes 5. What are theta? Our theta to be the tan inverse b over a. So our b is 3, a 4. So you get tan inverse of 3 out of 4. And then our theta becomes 36.52. So it becomes 5 multiplying cos of 6.52 I sine of 36.52. So we've actually changed which was in the vector to the polar form. Conversely, you can also change the polar form into the vector form. I mean, this is algebra. It's just a matter of just finding the cosine of the angle and the sine of the angle and multiplying 5 through them. Alright guys, thank you very much. Do well to subscribe to my channel for more videos. Thank you.